Okay, you can hear me? Thank you, Daniel, for having us and for introducing me. So my talk will be about measuring Kamailio, but actually it will be your 7 steps to lunch. So I'm the only one preventing you from having lunch, so I try to be quick. We will talk a little bit about our company, Pascom, what we are actually doing. And then the actual topic is monitoring with Prometheus. Some Prometheus users here already, who knows it? A few of you, yes. Then we wrote a tool for it called the Kamailio exporter, so I will introduce you. It's open source. And then there are a couple of other projects that play with the idea of integrating Kamailio with Prometheus. And then finally, we will show it Grafana, building dashboards out of your data. Yeah, and hopefully we have time for a few questions before we really go into lunch as step 7. Okay, about us a little bit. As Daniel mentioned, we are not a video production company. So we do it for fun, not for money. Instead, we build, like most of the other people in here, SIP-based solutions. We use mainly Kamailio and Asterisk. And we try to focus on security and usability. So we try to do secure and beautiful SIP at the same time. And so we have also CTI and voice over IP clients for all the 5 major platforms. Yeah, not to forget we are hiring, so if you search a new place, just approach me. Okay, before I really start into the talk, I first want to thank the Kamailio team for implementing Kimi. It's really a great interface. We converted all of our config files to Kimi, Python in our case. And actually, we never looked back. So it's really great. If you're not using it yet, you should definitely have a look at it and start using it right now. So who is using Kimi already in some flavor? Okay, some people. Yeah, let's start with monitoring. Why should I do monitoring at all? The goal is, if you collect enough data, you can do some kind of a forecast, like a weather forecast. Probably it allows you to tell, will my system operate safely at night or not? What happens if I get so and so many new subscribers in the next week? Do I have to scale out or not? Yeah, and so the goal is you want to be able to sleep at night. If you have enough data, if the forecast is well, it allows you to be a SIP engineer having a family at the same time. But as with most forecasts, sometimes it's not so reliable. So it can happen that you did all your homework and looked at the metrics and everything, but still something unexpected happens, and yeah, night was not so long as expected. But still, monitoring has a benefit in this situation because possibly you can debug by looking at the data what really happened, and improve your monitoring and forecast for the next night. And to do this, we are using Prometheus. It's a little bit different like traditionally monitoring tools like Isinga or Zabbix, so it has a few different ideas, and I want to introduce you a little bit to the philosophy of Prometheus. So first of all, it's an open source monitoring system, so it's not bound to any particular company. It started out at SoundCloud here in Berlin, so it was an in-house project which was open sourced later, and now it's independent of any company. It's Go-based. It has a very simple deployment model, so you can start with just one process on one node. You don't need an extra database. Database is embedded. And it has a very interesting data model. You don't get flat metrics, so you don't get, let's say, just the number of requests. Instead, you get something like number of requests of type invite or of type options or whatever. So you can attach a number of labels to each of the metrics. So it's a multi-dimensional data model. Good examples are, like mentioned, the request type or response code, something like that. Bad examples are, however, a UUID, an IP number, the user agent of a phone, because it would simply overwhelm the data. So you need to choose wisely what to attach to these labels, but if you do so, it gives you a lot of benefit. Last not least, it has a powerful query language to get the data out of it again. It's called PromQL. It's totally different to SQL, actually, but yeah, they need to choose some name, so it's PromQL. And also you get a whole bunch of client libraries and integrations. It's still quite a young project, but adoption is great. And so you will find a lot of related APIs and projects in the internet. Yeah, what's the idea about Prometheus? They basically saying checking the CPU, the memory, and the disk is not enough. We did this in the old days. Is the machine fine? Do I still have enough disk space, and so on? But nowadays, everything is highly dynamic, and then it's not enough to check these basic things. Instead, they say we don't want to limit monitoring to the stuff that is going into a service and out of a service. Actually, we want the data from the service. How much memory does it consume? How much time does it spend in a particular function or something like that? So their idea is actually that all the services gets enhanced with Prometheus API to instrument each service directly, to get all the internal data out of it and put it into this database and have it in the dashboard and doing some forecast based on it. But of course, you can also have CPU, memory, and disk if you want. Okay, how does it look like? It starts very simple. You just have one process. You download it as a binary. It doesn't have any dependencies because Go-based. You start it, you give it a directory where you can store the data because database is embedded, and you're ready to at least play with it. To play with it, you need some target, some service that you want to get the data from. And Prometheus will do regular HTTP gets on this target. So it's different also than other project. The data is not pushed into Prometheus. Instead, Prometheus will pull for the data. You can, of course, define how often this happens, typically every 30 seconds, every 1 minute or 2 minutes, depending on your needs. And depending on the amount of targets that you have, it will schedule those GET requests in some manner that it will work on your hardware. Okay, the protocol itself is actually text-based, so it's very simple to debug. You can also use HTTPS, of course, and authentication if you want. But for playing with it, using HTTP, checking the protocol is really simple again. Okay, next step, you can also push data into it. This makes sense if you have targets which are not living very long. If I have a batch job in example, which runs for 5 seconds, Prometheus would not get a chance to really ask it for the data. Instead, in this case, you collect the data in your batch job, and then you push it into Prometheus. But in this case, you need a second process. It's the push gateway. So you can set it up, or if you don't need it, you don't set it up. Then, usually you don't have one target. You have a lot of targets. You have some cluster. You have some cloud system. You use Kubernetes, maybe. And in this case, Prometheus can also talk to your cloud system and add targets dynamically. So if you spin up a new pod or something like that, or an EC2 machine, you can tell Prometheus to automatically scrape a specific port on this machine without really changing the configuration. Then you can again use HTTP to query for the data. So it's, like usual, exposed port. You can use the browser or something else to do queries against it. It also brings a small UI for playing. And in this way, also Grafana or other dashboard solutions connect to it. So also nothing special, simple to debug, simple to understand. Finally, you can set up another process, the alert manager. If you really want to wake up people at night, you can set up alerts here. It has a very flexible rule set here. And then send alerts via various third-party things. In the simplest way, you can send out an email or SMS or something like that. Okay, so that's basically Prometheus. And next topic is the Kamailio exporter. That's the project we did. But what's an exporter? It's a term that was, I think, introduced by Prometheus, and I tried to visualize a little bit what the idea about it is. So the problem is metrics are usually hidden inside a running process. Of course, if you would have a process which was built for talking to Prometheus, it would be simple. It would be directly exposed. But in the case of Kamailio, it doesn't have some way to expose the data. So we have the operator here and Kamailio. And in order to read the data, we can leverage an interface. We can leverage the existing bin RPC interface of Kamailio to get out the internal statistics of Kamailio. And then we can convert it into HTTP. Prometheus will scrape it, will poll for it, and finally you can see in the Grafana dashboard what's going on. So what's the exporter? Now in tech speak. Actually, it's a service which exposes metrics from another service via HTTP. We're not the only ones building exporters. There is a huge range of exporters available for all of the major databases like Postgres, MySQL, also Redis and other things. There is something called the node exporter. It's not written in Node.js. It's just maybe unhappy choice for a name. And the node exporter exports a lot of machine-level data. So here you would get the usual memory, CPU, detailed networking statistics, I/O, and so on. And so it's quite easy to pick also this up and export it to your Prometheus. You can check the Prometheus website to get a list of exporters. And you will see it's quite large already. Okay, but basically exporter is always used if a direct instrumentation is not available. So the best choice is if you build a service to directly use Prometheus API and expose it directly in your service. Yeah. So that means if I want to use this Kamailio exporter, it's not a module, it's a so-called sidecar. It's an extra process. I run it aside of Kamailio. If you're into containers, it's another container talking to Kamailio, exposing it via HTTP. It reads this internal Kamailio statistics with bin RPC and exposes it to Prometheus. It's also self-contained, Go-based, so you can download binary from the GitHub and try it out very simply, even without a container. And because it exposes as HTTP, you can even try it without having Prometheus at all, just pointing a curl to it, and you will see what's going on. So here is the URL. You can grab source code from there and also the binary. It's a quite young project. We built into it what we personally needed for our environment, but of course, you can contribute more stats into it. Yeah, what it does at the moment is it exposes the core requests and replies with method and code as labels. So like mentioned before, you will get number of requests, type whatever, invite, number of responses with the code, 200. You will also see, very interesting, the Kamailio shared memory details. You will get some summaries about stateless and transaction modules. And also important for us, you get the TCP statistics, so connected TCP or TLS sockets. Then there is a feature to script metrics. We didn't write a new Kamailio module for it. Instead, we used an existing one. There's a module around called statistics. And it's very simple to use. You load it, of course. Then you define for each of your values a module parameter. In this case, it's softphone register total. And then whenever you think it's time to do it in your script, you just increment it by 1 or whatever makes sense to you. And that's actually all. Then this exporter will pick it up automatically, and it will be stored in this Prometheus database, and you will see it in Grafana. So that's quite useful for whatever business case you have. Okay, next step is other projects. We are not the only ones integrating Kamailio and Prometheus. Last year, and also this year again, I think we see Haplify from the Homer 7 project. They also talk to Prometheus. In this case, you will not get something like the memory stats of Kamailio, but you get very fine-grained details about your actual zip traffic or things like the MOS score from the RTB engine and stuff like that. So call-related detail, not really process-related details. And there is, funny fact, there is another guy that wrote almost the same project like we did at almost the same time. I talked to him, and we will eventually merge these two projects. He has support for the dispatching example, but he lacks this scripting capabilities. So there is some overlapping, but in combination, it would be best solution. Funny is, if you look at the logo, it's almost same logo like we have, but in blue. So you can choose between the blue or the red exporter if you want. Okay, then next topic is Grafana dashboards. So obviously, just putting something in a database is a bit boring. We want to get to this weather forecast-like thing. And so you want to visualize it a little bit. I think there are quite some Grafana users here already. Is it? Yes, more than Prometheus users. So what is Grafana for the other people? It's an open source, feature-rich metrics dashboard and graph editor. And a nice thing about it is that it is not tied to a particular database. So you can use multiple backends. In our case, we're using Prometheus, but you can also use it against Elasticsearch. And very interesting, there is also a backend doing SQL against Postgres database. So whatever business data you have, you can possibly combine it with some metrics. Okay, typically you use it for something like this. It's complex, and it's a dashboard for monitoring a Postgres database. So just to have an impression what it can do. Personally, I think it's too much graphs on one dashboard, but yeah, that's something you can do. But you can also do something else. You can build SEO-ready dashboards with it, with just a few numbers. So this is an example out of our software for one tenant to get the call data summaries. We use it also to get statistics of app queue and something like that. So there are quite some usages. But yeah, if you want, you can also do this. Okay, then I have a final example. I need to check the watch, so we have still a few minutes. The final example is actually a dashboard that we're using in production. It's very simple. It looks like this. It's 3 panels. In the upper panel, you see requests. In this case, it's invites. In the middle panel, you see the shared memory of this Kamailio node that we're monitoring here. And in the lower panel, you see the number of connected TCP or actually TLS sockets. So that means in a typical workday, you will see here around between 8 and 9 o'clock after first coffee break, people are starting soft phones. So we're not starting here at 0 phones. It's already 2.3K desktop phones. But the people that are using a soft phone, yeah, you will not see the registers, of course, until they turn on their device. So they start working here, and you will see some grow until something around 10 o'clock. Also, traffic, of course, grows. And very interesting, you see the shared memory of the Kamailio is more related to the number of sockets and not so interested actually in the number of requests. You can see this also here when it's lunchtime, so in a few minutes, that the memory is not really dropping. It's holding the same line because the people are not turning off their soft phones, but traffic is reduced. And finally, here it's time for the cocktail party later today. And people are, again, stopping their phones, and you see that Kamailio recovers its memory. So that's something that you can build with our project and Prometheus and Grafana. It's a simple use case, but still useful. Okay, perfect in time. Do you have any questions?
Yeah, hello. Nice to see. This idea was Prometheus, and in our company we have the Prometheus guys and the Influx DB guys. So the one is pull and the other is push. And I must search for my own name on the mailing list to see how I solve this. I don't use the exporter because I use at myself JSON RPC calling in the scripting language of Kamailio. And so I get JSON from Kamailio with all the data. Mm-hmm. And you can search it on the mailing list. If you don't want to use Prometheus, you can do it with Telegraph and fetch it and pull it to your InfluxDB.
Okay.
So that's another kind of
different
making
solution
this
for the same problem with different database at the end. Yeah.
Okay, so here we have Sebastian in good mood after being a captain last evening.
Hi. Speaking of Telegraph, I noticed that there is a Prometheus output plugin. Was it already there when you started programming your exporter, or why didn't you use the Telegraph for getting the data into Prometheus?
Because we used Prometheus before. And actually, I was at PromCon in Munich, and I thought it would be a good idea to integrate it somehow. So we had a running Prometheus solution in our stack already for doing this machine level thing and getting metrics from other systems. And so for us, it was just logical to also put that data into Prometheus,
Yeah,
without having Influx or Telegraph or something else.
Telegraph can directly export it to or can, I think, set up a socket where Prometheus can pull the data from.
Okay, I didn't know about it, really.
Yeah, it's
And
an output
the guy with the
plugin
blue
for
logo
Telegraph.
didn't know about it either, so I'm not the only one.
Yeah, and by the way,
I can have a look at it. So it will do the same data, or can it do more or less? Or?
yeah, you can exec some CMD queries, and then you can export it and have a socket where Prometheus can read it from.
Yeah, but then it's actually same.
Yeah. And you need more private customers, by the way.
Okay, one more question there?
So your exporter, does it do periodic probing and caching, or does it query every time on demand?
It's as simple as possible. Prometheus will do a HTTP GET on it. It will do a stats fetch on Kamailio using binRPC, and it will convert and export the data.
So you don't have a problem with load spikes or anything during the
It's very predictable, because I know that Prometheus will not ask it more often than, let's say, once per minute or once per 30 seconds. So there are very few surprises. Of course, if you have a farm of Prometheus, if you do HA or some cluster, you will double or have more requests, but still it will be predictable.
Yeah, I'm just curious about the load of the binRPC queries for the statistics.
Of course, it would be possible to build a cache inside of it, but for now we didn't see the necessity to do so.
Sure.
Okay, thank you. Not to make it longer.
Thank you.